So good afternoon, everyone. Andrew Kloffenstein. I'm a senior research engineer for Department of Food, Agriculture, and Environmental Engineering at Ohio State, and I'm going to go into more in depth. We're actually working on a collaborative project with Iowa State on this 360 rain unit. And show of hands, how many people have heard of the rain unit? Awesome. So um, we saw this technology, and we worked with one of the engineers, and we developed an objective. And we worked with a couple different entities, NRCS, as well as Ohio Department of Agriculture and H2 Ohio, and those are giving dollars for some of these practices or research to demonstrate them. And we wanted to look at commercial and animal nutrients and look at a unified strategy for nutrient loss while improving grain yield. So I'm not going to spend a bunch of time on the specs, but hopefully if you have questions on this, just ask us after the fact. One thing I really wanted to point out was the fact that this unit, what it does is it opens up irrigation and nutrient application to any field shape. So like we're really bound when we think of a center pivot to a circle, but we cannot move that asset around. We can literally move this asset, and we do in Ohio move this around. It does take a bit of effort, but it is not tied to a specific point. We can move that around. We can change the path seat year, and we're seeing growers change the way they farm the field just to utilize this asset. So a quick video, just in case you haven't seen it. So this was from this summer, and um, you have 3,000 feet of hose, and then you water on the outside going out, and this is showing that. And what I want you to pay attention to is the liquid. So we see the liquid banding. You can have nutrients in there, you can have manure, pretty much the sky's the limit. So you see I'm going out. We actually apply a higher rate. We average a ½ inch per pass. And what I want you to see when we turn back around, this is a 45-second video from start to finish. Look behind it, and you're going to see that everything is completely soaked in roughly a minute. One of the beauties of this is people ask, well, what happens when you have runoff? There has been 0 incidents where we've had any runoff or anything hit the field tile. So we talk about when we're putting those nutrients on, one of the risks is what? We have runoff. So we control this unit. We do randomized strip blocks. A lot of these fields does present a challenge because you're out there trying to do this on regular operating farm. And we have our strips. We go out. It's all controlled from your phone. I could literally talk a ½ hour about my experience with this, and I happy to answer, show interface, but it's all controlled from your phone anywhere where you have cell phone access. If the unit does not have cell phone access, it will shut off and it will not start again until you have that. So just keep that in mind. We have had that or a power outage at the base station. It does have its own local RTK network. We are focused on in Ohio. I'm going to talk a little bit about animal nutrients, but we are doing the commercial nutrient side, and we are pulling our liquid from a well. So just a quick overview. This is our well. Comes up, we go to a valve, couple pressure sensors, and then we have this tote is full of commercial 32, and we inject that into the water stream. Now I'm going to get questions. Well, what if you all injected it? Literally, you can anything you want to put in the water stream, you can. So we inject that in, comes around, goes here. We have flow meters and a booster pump, and we boost that pressure up and send it a mile. It's a mile away from where that unit is. We also have this other hose that comes in, and that allows us also to demonstrate we inject different manure sources. So you can have swine, dairy, whatever it may be, but that's to demonstrate that. So I'm going to give an example, and this is just one example of application. I'm going to focus on an 80-acre field. If we were trying to put on a ½ inch, we'd be talking roughly about 1 million gallons on an acre, on 80 acres. It would take roughly 3.8 days to cover that field at 200 gallons a minute. And if we wanted to do a 50 gallon per minute injection of manure on that pass, we'd be putting in roughly 270,000 gallons. So as we look at this, there's infinite flexibility. You can change your rates, put on whatever. You can also start to do variable rate with this. We have a couple different sites I'm going to report on today. And again, there's lots of data, so I'm going to be going through this quickly. There's the Iowa State portion of this. I'm not touching on that at all today because just time. But we have a Beck site, and that is literally looking, it's a paired watershed. We have water quality monitoring on half or on both halves, but one side is commercial standard practices, on the other side is using the rain unit. Field 7 is randomized block design, and we have three different treatments. And then we have, quote, our sandbox, which is field 8A. So what I want to cover on this slide are these three treatments. The three treatments are commercial fertilizer, non-irrigated, commercial fertilizer, irrigated, and then commercial fertilizer and 2/3 the nutrients. So we're cutting back the amount of in-season applied product, which for us in Ohio typically is only nitrogen. So the first year that we had this unit in 2023, we had irrigated versus non-irrigated Beck's hybrids. We had 226 versus 218. Due to COVID, this project got delayed. Sort of sick of hearing that, but it took a year to get up and running, and then we didn't get that unit in time. So we had modest results. We only had obviously 8 bushel the acre increase. That is probably the biggest reason we didn't see a whole lot of differences. In our other field, this was our sandbox. This was corn as well. We did essentially a nitrogen study, different rates. And what we learned from this, again, we have to really see the full benefit, but we saw that the economic optimum for nitrogen was actually 170 units per acre, regardless if it was irrigated or non-irrigated. But if you look at that paired treatment, so what I mean by that, so if we look at the 170 irrigated and non-irrigated, we always had a statistical difference based off watering, which I don't think that's anything new. We know water is always going to win when we look at that. So this last year was our first full season that we got to use this unit. We put on a total of 5.5 inches over 11 applications in field 7. We injected our nitrogen, which was 28% over multiple passes. And this was when we pulled our ears in late July. Field 8A, we put on 4.5 inches of water, and we actually did 3/4 of an inch per application pass. And then we actually never watered over at Beck's due to the fact that we had a well failure and the well collapsed, so we never got to apply there. We can talk about that later too, but we're not going to get into details. So this is pictures a month later, again, looking at differences in ear size. And I'm really going to drive home this point. Soybeans really responded in a way that we weren't expecting, and we'll talk more about that. So aerial imagery from the fields. We have our non-irrigated strips throughout the field, and then our irrigated on this bottom corner is where we soybeans, just to give you an idea of what that looked like. So results. So field 7, irrigated, we had 233 bushel. Irrigated with 2/3 the nutrients was 237. So there was no statistical difference reducing our nitrogen by 1/3, which is pretty exciting. We start thinking about reducing nutrient application by 1/3. And then we look at the non-irrigated, that was 189. For total these are some other numbers. We used 773 gallons of diesel fuel in total for 71 acres across those passes. And we used a total of almost 26,000 kilowatts of energy. So that 26,000 kilowatts is actually running the booster pump. In soybeans, this gets everybody excited. 36, which is 50 bushel. It's 36 bushel. Um, we're going to get to a point in that growing season where it's probably going to make sense. We're going to maybe switch which crop we're watering. It would make more sense to water soybeans versus corn, at least in Ohio. Now, growing seasons vary, but again, this was something that we saw this past year. What is getting us really excited, if I can play this video, is coming in 2026. They are coming out with a new, what they call a nutrient injection skid, and we're actually piloting this product this year. And what this allows you to do is put in granular product into the water stream. So any granular product that you can imagine, you can now inject into the water stream, and this includes seed. So yeah, pretty exciting. You start going to a grower and you can tell them that you can put on uh, anything you can imagine during the growing season. Um, I got asked at the last place I talked, well, what's in your mix for this year? The question is, it changes every time we have a meeting. Um, so this was one example from a year ago, and we were in severe drought in Ohio, and they put alfalfa out in August. And then they seeded this in, and this is the result they got in August. And we didn't receive hardly any rain in like June, July, and August. So pretty exciting as far as what we're looking forward to. So conclusions, um, this opens up irrigation and nutrient applications to places that typically don't have high volume water. Ohio, the majority of Ohio does not have access to water. While we get 38 inches of rain a year, we're primarily dry land, but now we start looking at these different fields differently as far as putting on nutrients in water. We also gain an efficiency by putting the water at the base of the plant, and we don't have evapotranspiration. We have efficient delivery of nutrients, and I don't think we've barely scratched the surface on what we can do as far as applying nutrients and what we can pull out. And what I mean by that, well, if we can put on a third less the nutrients, what that really, the implications of that. And then applying manure in season for the entire season over multiple passes is a game changer for us in Ohio. And as far as getting that on, when we look at typically when that manure is put on, it's in the spring or fall, our risk is very, very high for runoff. When we put it on in the summer with an active growing crop, very, very little. And then that solids injection skid will completely change how we look at applying nutrients. We offered this to a grower and we asked the grower, well, what's your nutrient plan? His nutrient plan was, I'm no longer putting on any nutrients in the fall, no more spinner spread. So we talk about how that is going to change going forward. We're pretty excited. So just want to, we're been very thankful for those that are supporting us. I just want to open it up for questions.